Hello, welcome to my channel. I am Ameya, and today we are going to see uh, Ansys APDL, and in that we will be solving the truss problem. Okay, so let's see. I am opening Ansys APDL with working directory and job name, and let us start with our problem. Okay, so just allow the yeah. Yeah, so I have Ansys APDL. So let us see the problem what we are trying to do. So we have a truss problem here, and two ends are supported. There is a load in y direction, negative y direction. Material property area and E is also given. Starting with the element selection, the truss is again a slender beam which generally takes load at the joints, and we take as a link element for truss so that we can solve it quickly. So you can go to preferences, select a structural problem, preprocessor, element type, add, edit, delete. We will add a link element into my system. Okay, close. Then you will be having no real constant for link element. You will be going to material properties, material models, structural, linear, elastic, isotropic. Usually we do the same thing most of the problems. So 2E5 and zero point 0.3 as your Poisson ratio. Material is added. We'll close this. Then you will be going for sections. You will go to link, add, section number you will specify first, and let us name it square section SQ1, and area, let's see what area is given. It is given 100 mm square. Okay, so I am entering 100 mm square, no change of units. Okay, so what will be the next step? Next step will be the modeling. Now, what we need to understand in truss is we need to take this complete 300 length as one single element. Okay, and same goes to element 2, which is the inclined element. Okay, so there is no point of sizing in your truss. Okay, so you can either there will be two approaches. One, you can create key point line and you can mesh without sizing, so whole length of the section will have one element, or else you can go with the key point, sorry, nodes elements, and directly create the element with respect to the given dimensions. Okay, so we will be doing with the first approach for now, just to understand. So I will go to active coordinate system. First I will create at 0 0, then 300 0, and then 0 400. I need 3 points, right? So I have these 3 points. Then I will go and create lines, straight lines. Only two lines I need from this point to this point and this point to this point. Okay, yeah, plot multiplot. Now, after creating lines, we will go to meshing, but in meshing, we need to make sure that attributes first. So there is no change of element and change of element section. There is only one. So attribute will be same. And then in sizing, it is very important. In sizing, you will be creating only one element throughout the length. Okay. So number of element divisions will be one. So that will make only one element throughout the length. Okay, and this is the only case for the truss problem. So wherever you solve truss, we always make it a one element, complete section as a one element. Okay, so don't forget to do that. Then you can go to mesh, select both. Okay, this will be your final mesh. and then there will be a load. So let's see the loading condition. Loading condition is fixed support and the load of 2 kilonewton. Okay, so I will go to loads, define loads, apply structural displacement on key points. I will select both key points. Okay, all degrees of freedom fixed. That will give you the zero displacement, fixed supports. Then you will go to structural force on key point. This key point I will select, and here I will be selecting Fy because it is in y direction, and if it is going downwards you will be selecting the minus values, and if it is upwards you will be selecting the positive values. Okay, so here I will be entering minus 2000 because value is given in kilonewton. You will convert it into a newton. Okay, yeah. Then you can go to solution, solve, current ls, there will be solution done. Okay, you will get error if you do the sizing. If you do the single element, that will not give you the error. Okay, then I will go to plot results, contour plot. Let's see the deform shape plus, deform plus undeformed. Yes, so there is a deformation in the y direction. Yeah, so contour plot, nodal solution, you can go to DOF Z total displacement. Okay, that will give you the graph for total displacement. I will go to list results. I will show you what kind of things we find in Truss. So I will go to nodal solution, displacement vector sum. That will give you the displacement in X, Y, and Z. So we are interested in node number 2. So in X direction will be your U2, U3 or U2, V2 and the total vector sum. Also we are interested in the reaction solution. So you can go to reaction solution, all items. That will give you the reactions at the fixed support. Node 1 and node 2. In node 1 there will be only Fx, and in node 3 you will get Fx and Fy, the combination of the reaction. Okay, these are the general things which you find in Truss. Now what we need to find is again stress, the last step. So you will go to read results, last set, we will read the last set. Then you can go to element table, define table, add, edit, delete. You can go to by sequence number. We are using link element, so you can just go and select the ls1. Okay, close, and then you will be going to list results, element solution, stress, and wine mass stress. Okay, and that will give you the stress in the element. So one element will have stress of minus 15 and one element will be having a stress of 25, and one is in compression, one is the tension, so you can easily understand that. So we have found out the displacement, we have found out the reactions, and we have found out the element solution stress using the element table. Okay, so this is how you get the different values for Truss. Let us verify our answers. We are getting U2 and V2 as same, reactions are also same, and then stress is also minus 15 and 25. So that gives you the solution for Truss problem. The important point which we need to remember here is whenever you model a truss, always make a single element for a complete section from one point to other point. Okay, don't go for sizing. That is the only takeaway or the different thing which is there for the truss problems. Okay, so if you like this content, do subscribe my channel, follow my channel, and share a word about channel with your friends. Thank you for joining.